Alright, so this is matrix multiplication. So we have a couple matrices like this and this. Can we multiply them? So first of all, we need to go over a couple of rules. So when the inner dimensions are the same, that's when we can multiply. So I'll give you an example in a second. The outer dimensions are going to be the dimensions of our answer. So here's an example. If A is a 2 by 3 matrix and B is a 3 by 5 matrix, first of all, does order matter? Yes, absolutely, order matters. So if we were to do A times B, that's a 2 by 3 matrix times a 3 by 5 matrix. I've written the dimensions, I just usually write them like that. And then since they line up, or since the inner dimensions are the same, that's what I'm referring to here, you can multiply them. And because it's a 2 on the outside and a 5 on the outside, it's a 2 by 5 answer matrix. Now if we were to try and multiply the other way, it's a 3 by 5 and a 5 by 3, that won't work. So that is not defined, is what we would answer. You cannot multiply those. Alright, so let's go over a very good key example. So when we're multiplying, it's not like regular multiplying of numbers. Matrix multiplication is a specially defined operation, where we multiply each row entry by column entries. Thanks, Mark, for helping me spell column. And then we add all those products. Alright, so let's go over that dimensions thing again. So if we're doing A times B, that is a 2 by 3 times a 3 by 3. So I just wrote the two matrices down there. Because the inner dimensions are the same, we're allowed to multiply the matrices. And then the outer dimensions, those outside numbers, are going to be the dimensions of our answer. So we're going to have a 2 by 3 matrix for our answer. So what we're going to do is multiply rows by columns. So the first row times the first column is going to give us the first row, first column, so first row, first column entry. So in our answer matrix, that's going to be a 15. So what we're going to do for the second one is do the second or first row times the second column, and that's going to give us the first row again times the second column answer. So that's going to give us our answer right there. So we multiply each of them. So what you're doing is we're multiplying the first times the first, second times the second. So that was 3 times 3 is 9, and then 1 times -1 is -1, 4 times 4 is 16, and then add those together to get 24. Slow that down a bit. So now we're going to multiply the 3's, the 2, and the 4 to give us that. Gives us a -3. So now we do the bottom row and first column. So -1 times 1, 2 times 4, and 3 times 2. Add those together, get a 13. Next is going to be the bottom row middle column, which is going to give us our answer right here. So that's bottom and middle. Multiply them all, then add them together, get a 7, again with the last one. And then that's our final answer matrix, a 2 by 3 matrix. So you may want to pause or rewind that and just see again, but essentially it's just whichever row and column are being multiplied, that's going to be the entry. So if it's bottom row middle column, then it's the bottom middle entry. Once you multiply the first times the first, gives you that, second times the second, gives you that, third times the third, gives you that, add them all together, gives you that. So for this, it's a 3 by 3 times a 2 by 3, so the matrix B times A cannot even be multiplied, so that's not defined. So here's a couple of examples I'll do in another quick video, just to show you kind of some weird ones. And then here is an example for you to try on your own. Why didn't that show up yet? There we go. There's an example for you to try on your own. So go ahead and try that. And then the practice that's going to be due next class is going to be, I guess I don't have it. Alright, so just check Moodle and that'll show you what we're going to do next class too.